Okay, so let's solve some more trig equations, and this time we're going to be using the identities that we've previously talked about. So let's look at the directions. Find all solutions of the equation on the interval from 0 to 2 pi. Okay, so things that I would be thinking about is, remember our cheat sheet that we talked about. So these are the things that I would want to be able to recall easily. I think unit circle for those quadrantal angles like pi over 2 and pi. We want our special triangles. We want to know where, each function is positive, where it's negative. Those kinds of things I would want to kind of keep in my mind at all times. And then you're also permitted to use the formula sheet that is provided to you. So the other thing that I would be thinking about, as I've got my formula sheet right here, is how are cotangent and cosecant related? So if I look at these Pythagorean identities right here, we know that 1 plus cotangent squared x is equal to cosecant x, right? That is one of the Pythagorean identities. And so I can use that to help me solve this equation. This equation is going to be a lot easier to solve if I have it all in terms of one function. So since the Pythagorean identities deal with squared functions, I'm going to go ahead and square both sides of the equation, and then that will enable me to make a substitution with the Pythagorean identities. So remember, if I square this side of the equation, then that's actually cotangent x minus 1 times itself. And then squaring cosecant x gives me cosecant squared x. So I'm going to have to FOIL right here, right? So cotangent times cotangent is cotangent squared x. Outside would give me minus, so negative 1 times cotangent x is minus cotangent x. Inside would be exactly the same, minus cotangent x. And then last, negative 1 times negative 1 would give me a positive 1. And that equals cosecant squared x. Okay, so let's see. Collecting like terms, I can combine these two. So this gives me cotangent squared x minus 2 cotangent x plus 1 equals cosecant squared x. So now that I'm dealing with the squared functions, I can replace cosecant squared x with 1 plus cotangent squared x. So I'm going to make that substitution. Instead of cosecant squared x here, I'm going to write 1 plus cotangent squared x. So we have cotangent squared x minus 2 cotangent x plus 1 equals 1 plus cotangent squared x, making that Pythagorean identity substitution. So now I have this equation all in terms of cotangent. So I want to get everything to one side. Let's set this thing equal to 0 and see what we have. So notice I have a cotangent squared on both sides of the equation. So if I subtract cotangent squared x, those will 0 out. I also have a 1 on both sides of the equation, so subtracting 1 on both sides, that will also 0 out. So all that's left is negative 2 cotangent x on the left and 0 on the right. So now let's get cotangent x by itself. So I'll divide both sides by negative 2. So cotangent x is equal to 0. And so now I'm, of course, solving for x. Since I have this equal to 0, again, when I'm going to think about unit circle, right? And since cotangent x is cosine over sine, that means cotangent x will equal 0 wherever cosine is 0, because 0 over 1 is equal to 0. So if that's cosine over sine, I'm basically looking for where is cosine equal to 0. So remember, cosine is the x coordinate, so I would be looking here and here. So at pi over 2 and at 3 pi over 2. So x is equal to pi over 2 and also 3 pi over 2. Okay, so now we have to check our answers since we started by squaring both sides of the function. So we have to check. So let's do that. So let's check. First, let's check x equals pi over 2, and we want to go back to the original equation to do that. So the original equation would be cotangent, so of pi over 2 minus 1 is equal to cosecant of pi over 2. Okay, so we know cotangent of pi over 2 is 0. So 0 minus 1 is equal to cosecant of pi over 2. So that would be just 1 over 1, or 1. So we end up with negative 1 equals 1. So that is not true. So that means pi over 2 is not a solution. So let's now check 3 pi over 2. So again, going back to the original equation, cotangent of 3 pi over 2 minus 1 is equal to cosecant of 3 pi over 2. Okay, so cotangent of 3 pi over 2 we know is 0. Minus 1 is equal to cosecant. Again, we're thinking about 3 pi over 2 down here. Cosecant is 1 over sine, so that would be 1 over negative 1, or negative 1. And so this one is going to work. So I actually just have one solution, and that is 3 pi over 2.